Geometry, section 4.3, proving triangles congruent, using the side-side-side and side-angle-side congruence postulates. By the end of this lesson, you should be able to identify what included angles are, and you should also be able to prove triangles congruent using the side-side-side and side-angle-side congruence postulates. So taking a look at what we had covered in the last lesson, we talked about congruent triangles and what it means for triangles to be congruent. We had said that triangles are congruent if all of their corresponding angles are congruent and all of their corresponding sides are congruent. So looking at a proof that we had done in class, we see that we had proven a pair of sides congruent here, another pair of sides, and our final pair of sides here. And we also proved a pair of angles congruent, another pair, and this would be our third pair of angles congruent. So there were 6 parts of our proof. Even though we were given a lot of this information, we still had 6 things that we needed to prove before we can say that the triangles were congruent based off of the definition of congruent triangles. So what we are going to learn today are actually what you can consider a couple of shortcuts to proving this. The first one being the side-side-side congruence postulate. And the side-side-side congruence postulate says, if there are 3 sides of a triangle that are congruent to 3 sides of another triangle, then the triangles themselves are congruent. So here, looking at our diagram, we have an M congruent to RQ by 1 tick mark. We have MP congruent to QS by 3 tick marks. And we also have NP congruent to RS by 2 tick marks. So since we have 3 pairs of corresponding sides, then we can say that the triangles are congruent. So taking a look at what this would look like if we had known this information from our proof from earlier, we would now have a lot less that we'd have to actually prove. We would be able to get rid of any of the angles that we talked about being congruent. And when we're left with just the sides being congruent, then what we'd be able to do is to say that the triangles are congruent by the side-side-side congruence postulate. So we would take what our proof was before and pretty much cut it in half, because you are no longer worried about the angle measures if you're proving triangles congruent using the side-side-side congruence postulate. Our other shortcut or postulate that we have is the side-angle-side congruence postulate. And the side-angle-side congruence postulate says if 2 sides in the included angle of a triangle are congruent to 2 sides in the included angle of another triangle, then the triangles are congruent. Well, looking at this, we have a pair of sides congruent. So PQ and WX are congruent because they each have 1 tick mark. We have QS congruent to XY because they each have 2 tick marks. And what we call the included angle is the angle that is included or sandwiched in between them. You know that you're looking at the included angle if you're looking at the angle that's formed by the 2 sides that were the congruent sides of your triangle. So looking at this a little bit closer, the highlighted angle is the included angle. Now to see what this would look like if we put this into a proof. Here's the proof from before once again, and originally we had to prove that all pairs of corresponding sides were congruent and all pairs of corresponding angles are congruent. I'm going to pause right now because what you hear is my dog asking to go out. Alright, so taking a look at the proof again in terms of side angle side, we can get rid of a couple components. We don't need all of the sides. So to begin with, I'm just going to use the sides that were given to us in the given statement. So that means I don't need to worry about these last couple parts. What I'm also going to use is if we're talking about the 2 sides that were in the given, which were AB is congruent to CB and AD is congruent to CD, then the included angle, I need to be careful about what I consider my included angle. If we go back to our definition of included angle, it's going to be the angle that's formed by these two sides, or it's contained by the two sides. So the included angle that I am looking for now, if I move these markings so I can read my diagram, I'm looking for angle A and angle C to be congruent. Fortunately, when we had our given statement, angle A and C were already given to us as being congruent. So had you known the side angle side congruence postulate when we first solved this proof, you wouldn't really need to do anything more but list the givens. And instead of saying the definition of congruent triangles, you will now say that they're congruent based off of the side angle side congruence postulate. So knowing your postulates for triangle congruence can be very helpful, because without them, you'd have to prove all corresponding sides to be congruent and all corresponding angles to be congruent. And just like side congruence postulate, side angle side only requires 3 things to be congruent instead of the 6. But the important part is knowing the difference between which sides and which angles you're going to use for that postulate. So that pretty much wraps up our 2 shortcuts, which means it's time for our joke. And in Halloween spirit, we have another Halloweeny joke. And the joke is, why are there fences around cemeteries? Well, there's fences around cemeteries because people are just dying to get in. But don't bunch.